In this video, we are looking at Unit 3, Lesson 3, Associations and Categorical Data. Our learning goal is that we will look for relationships between categorical variables. Our essential question is, what would it look like in the data if two variables are related? The mathematical purpose of this lesson is to recognize association among variables by analyzing relative frequency tables. We learn that association between two variables means that they are statistically related to each other. The work of this lesson connects to our previous lessons because we created and interpreted relative frequency tables. This connects to our upcoming work because we will learn about relationships between two numerical variables. When we create and analyze relative frequency tables to make decisions about associations between two variables, we are looking for and making use of structure. In this table, we are displaying the dessert preference, cake or pie, and the dominant hand, left or right, for a sample of 300 people. For each of the calculations, describe the interpretation of the percentage in terms of the situation. So let's look at our numbers. We have 10% that we get by using the 10 and the 100. Let's find those in our table. The 10 is here at the intersection of our left-handed people and preferring cake. The 100 is the column total under prefers cake. So we interpret this by saying, of the 100 people who prefer cake, 10 of them are left-handed. Our relative frequency percentage here is 10 out of 100, or 10%, of people who prefer cake are left-handed. Let's look then at our 67%. That is 180 compared to 270. Here's our 180. Here's our 270. So we're looking at all 270 right-handed people and saying that 180 of them prefer pie. So that's 67%. We are saying 67% of right-handed respondents prefer pie. Our 30% we get by looking at 90 and 300. We find the 90 here at the intersection of right-handed and preferring cake, and our 300 is our total population. So that 30% of all respondents are right-handers who prefer cake. This is an and. Right-handed people and preferring cake is 30% of the total number of respondents. For the question about the 67%, did we use row totals or column totals? Think back to that table. We looked at the total of 270. That 270 came across the row by adding our 90 right-handers who prefer cake and our 180 right-handers who prefer pie. So 90 plus 180 gave us the 270. That is our row total. The overall total was 300. What if the overall total was 600? How many people would you expect to prefer cake and be left-handed? Well, if we double our population, would it make sense to double each of the cells within the population? I wonder. What does it mean for two variables to be associated? Let's read these examples and decide if the variables might be associated or not. The color of a car's seats and whether that owner takes the car to the dealership for maintenance or not. Or comparing the color of a car's seats and whether the owner is ever burned from the seats being too hot. What do you think? Which of these is a better picture of association? To explore more about association, we're going to look at some scientific data. This table displays data of 55 different locations of coral in the ocean. Scientists have a list of possible chemicals that influence the health of coral. They first look at how nitrate concentration might be related to coral health. The table displays the health of the coral, healthy or unhealthy, and the nitrate concentration. Is it a low nitrate concentration or a high nitrate concentration? Our purpose in this activity is to look for associations in categorical data. We have subgroups represented by rows or represented by columns, and they're not always equally represented in the data. So associations are often best recognized by considering row frequencies or column frequencies and then comparing across the categories. So what we are going to do on the next slide is create a relative frequency table using our column totals. So we're going to look at our nitrate concentration. We have 20 and 8 for a total of 28 measures in the low nitrate concentration. Then we have our high concentration where we have 5 healthy coral and 22 unhealthy coral for a total of 27 coral. We're going to use the 28 and 27 as our denominators to create our relative frequency table. So remember, in our healthy coral and low nitrate concentration, we had 20 coral samples. In our unhealthy, we have 8 coral samples, and we had a total of 28 total. 20 plus 8 is 28. And I'm going to use these to get my percentages. So 20 divided by 28 is going to give me 40. Let's see, that is not the number. 20 divided by 28 times 100 is 71%. Our unhealthy frequency is 8 divided by 28 times 100 will give me 29%. If I do 71% plus 29%, that is my 100% total. Now I'm going to look at my high nitrate concentration. My numbers here were 5 and 22 for a total of 27. So my denominator is 27. 5 divided by 27 times 100 gives me 19% if I round to the nearest percent. 22 divided by 27 times 100 gives me 81% if I round to my nearest percent. 19% plus 81% is my 100% total. So now let's answer question A and question B. When there is a low nitrate concentration, which had a higher relative frequency, healthy or unhealthy coral, which percentage is bigger, 71% or 29%? Well, you may notice that the 71% is higher, so that means our healthy coral has a higher relative frequency. How about part B? When there is a high nitrate concentration, is there a higher relative frequency in healthy or unhealthy coral? Well, 19% or 81% is bigger. Definitely 81%. So our 81% here tells me that unhealthy has a higher relative frequency when we have a high nitrate concentration. Because those percentages are so drastically different, we have 71% healthy versus 29% unhealthy in our low nitrate concentration, and 19% healthy versus 81% unhealthy in our high nitrate concentration. There's probably an association here. Just to be sure, maybe we should check our row relative frequency. Another chemical that scientists look at in determining coral health is silicon dioxide. So this relative frequency is based on the total for each column. Based on this data, is there a possible association between coral health and the level of silicon dioxide concentration? What do you think? Explain your reasoning. So we're going to look here at this 44% versus 56%. There's not really a huge gap there, but there is a bit of a gap between healthy and unhealthy. If I come over here to the high silicon dioxide, 46% and 54%, you know what? Those percentages are really pretty equal among my rows. So if I have low silicon dioxide concentration versus high silicon dioxide concentration, there's not really a big difference in those healthy percentages. There's not really a big difference in the unhealthy percentages. So is there an association? It might be worth noting that silicon dioxide is really the main chemical component in sand. Does that change your thinking at all? Are you ready for more? This incomplete two-way table displays the results of a survey about the type of sports medicine treatment and recovery time for 33 student athletes who visited an athletic trainer. So we have 33 total students. We have 12 of them who received treatment via ice. So how many received treatment with heat? Well, 33 minus 12 is 21. So here we have 21 total students treated with heat. What two values could we use to complete the two-way table to show that there is an association between returning to playing in less than 2 days and the treatment, ice versus heat? Well, we would want two numbers that add up to 21 and give us some drastic percentage changes. So here we might notice that 8 is double the 4. So I would probably want an invert here. So instead of treated with heat less than 2 days being double what's over here, let's try to reverse that. So two numbers that add up to 21 and one is double the other, I'm thinking 7 and 14. 7 plus 14 is 21, and 14 is double of 7. So here I could look at 8 is double 4, and 7 is half of 14. This gives me some pretty drastic comparisons when looking at whether students treated with ice are able to return faster than students who are treated with heat. Is there another possible solution? Maybe. It might be worth digging into. What about having no association? What two numbers could I choose for no association? Well, remember we were comparing 8 and 4. 8 is twice 4. What if I use those same numbers of 14 and 7, and I have 14 and 7 here? Looking at this, it didn't matter if we're treating with ice or treating with heat. Twice as many students can still return in 2 or less days, or in less than 2 days, and twice as many students can return in less than 2 days, whether treated with ice or heat. What two values were easier for you to find? Two values showing association or two values showing no association? As long as you can explain your reasoning, there's not a right or a wrong answer here. Our values showing association might be easier because we're looking for two numbers that add up to 21 that are not in a ratio of 2 to 1. So we just needed to change that. Different associations you could make. Here, Jada is comparing the age of children and young adults and their shoe preference. Jada surveyed 4 to 10-year-olds and asked if they prefer sneakers without laces, sneakers with laces, or shoes that are not sneakers at all. She asked the same question of 11 to 17-year-olds and of 18 to 24-year-olds. Take a look at this data. Jada concludes that there is a possible association between age and shoe preference. What are your thoughts? Here we have another two-way table summarizing data on writing utensil preference and whether you are right-handed or left-handed. I myself am left-handed, and I'm really not surprised at all that there's very little difference between preference of pen or pencil, because as a lefty, when I write, my hand drags across my paper and I end up with ink or lead all on the side of my hand. It doesn't matter. I am intrigued that 82 of 87 right-handers prefer pen and only 5 preferred pencil. Is there an association between dominant hand and writing utensil preference? What are your thoughts and what evidence do you have to support that? Our vocabulary association between two variables is when we have statistical evidence that one variable can influence the other. We can use that influence to estimate the value of the other. And that is it for this video.